Hello, I am Brock Stanton. I'm an aspiring meteorologist, and today we are going to be taking a look at this slight risk across portions of the Northeast, from portions of eastern New York up through portions of Maine. But then the severe risk will also span further south across portions of Pennsylvania, and we'll also take a look at the areas a little further south as well. I just really haven't taken a look at this marginal risk. I have not paid attention to what's causing it, so I'm not going to talk about that area just because I don't have enough information to make a decision on it. So here's the NAM. And also, I just realized I forgot to show our wind probabilities and stuff. So 15% wind, that is what is driving this slight risk. There could also be a few instances of hail, especially areas further north as well. And then the tornado risk is going to be very low end, but if there is going to be a tornado, it would be areas generally in that slight risk that have there's just a little stronger shear there. Still not much, but just a little bit, and we could see a tornado or two up in eastern New York through Vermont, New Hampshire, and western Maine, but that threat seems very low. So, getting back to the NAM3K, we are going to be taking a look at the reflectivity output, and this is how the model handles how storms fire and stuff like that. Basically, this is what the model thinks the radar is going to look like in however many hours from this model coming out, which was 7 a.m. this morning. And we can see how as we get into the early afternoon hours, this is like 3, 4, and 5 o'clock, how scattered storms fire, some Boeing segments seem to try and form throughout the area. You can see it looks like the severe risk will extend up into portions of southern Canada as well. Which is just going to be these hit or miss clusters of storms, especially further south. Storms will be in higher coverage further north. And combine that with just slightly more wind shear, and that's why there's a slight risk up there, compared to only a marginal risk or level 1 out of 5 risk for areas further south. But you can see as we move into the evening and more into overnight hours, that risk is going to rapidly diminish for severe thunderstorms because the instability or fuel for thunderstorms is going to be what is driving the risk for severe weather. And as that fades away, the risk is just going to fall apart because there is not much wind shear. It's change of wind speed and direction with height. But we're first going to be taking a look at our instability for this setup. And we're going to see how as we get into the day on Sunday, we have our pretty broad quarter of moderate to perhaps locally strong instability is going to develop here. And this is on the NAM3K. And, we're going to see how this gets used up as the storms kind of fire. And also I want you to notice is that some of these storms are firing out ahead of our cold front here. Our cold front's back here. But our storms are going to, a lot of the times the storms are going to fire out ahead of the front. And that's because there's not going to be as much forcing out ahead of the front. While storms are still going to form out ahead of it, it's much harder to predict where they're going to be. So it's just, especially for the marginal risk area, it's going to be very difficult to tell whether your area will get a storm nearby. It's going to be very hard to predict that. But, again, we're going to see how the instability as we get into the overnight hours just completely gets eaten up, completely goes away. We're also going to take a look at our moisture for this, and I just want to preface this before we show our other model, that the NAM3K, especially further north, is much more aggressive with the moisture return. So we can see by 18Z, this is 2 o'clock in the afternoon. We're going to see how, on this model, there's dew points in the upper 60s to 70s across a large portion of eastern Pennsylvania. I don't know about dew points in the 70s by this time. Upper 60s seems a bit more reasonable to me, and then up here, mid to upper 60s to even 70s dew points, and again, that seems a little more aggressive compared to what the other models are showing, so probably, I would think maybe like more low to mid 60s dew points, and that will make it feel maybe just a tiny bit less humid, and also maybe there'd be just a tiny bit less fuel for thunderstorms, but as long as it's more in that middle range of low to mid 60s, it would still definitely support enough instability to get that severe weather risk. Again, mostly damaging winds and perhaps an instance or two of large hail. The next thing we're going to take a look at is just to kind of see what one of our ingredients for hail is our lapse rates. And for severe weather, you generally want to see them over 6, so that, and then especially for large hail, I look to see the values of over 7, and that 7 shows up in those yellow colors. And we're going to see that we don't really have too much of that. This is again by 2 o'clock. The NAM, and again, the NAM has a little steeper lapse rates than the HRRR. And what lapse rates are there at rates at which the temperatures are cooling aloft. And I should emphasize that this is the rate at which temperatures are cooling in the mid-levels of the atmosphere. And these are generally 6 to 7, and that's sufficient for severe weather, but as I will show you later, the HRRR doesn't have quite as much as that. I tend to think they're probably going to be a little bit in the middle, probably right around 6, which is very marginal for hail. Combine that with the iffy shear, which I'm going to show you in a second, and the clustery storm mode, I don't think there'll be too many instances of hail. A couple are still possible. I think it's mostly going to be a damaging wind risk. I don't think the hail risk is going to be there too much. Small hail, of course, but I'm talking about severe caliber hail, which is quarter size or larger or 1 inch in diameter. I could see there being plenty of instances of small hail, but large hail I'm not sold too much on. And you can see how this is at 3 o'clock in the afternoon. How across the areas farther south into Pennsylvania, our bulk shear is generally 20 to 30 knots. That's marginal, and even further north, it's maybe like 25 to 35 knots. That's still very, very marginal. Our shears, this is our deep layer shear. It's very marginal, and that's really going to mean we're going to be looking at clusters of storms. We're not going to be seeing supercells form, and that's another reason why I think our tornado risk is going to be so low with this setup. That, again, I don't think there'll be anything across like Pennsylvania and Virginia and Maryland, but maybe a little farther north there could be a little bit of one. And the reason I do believe there could be that maybe at low end risk of tornadoes is we can see here that there's going to be a little bit stronger 850 winds up here. If we take a sounding in here, I think we would see an environment that could be somewhat supportive of a tornado. Still not much. That risk is going to be very low. These 850 winds, this is what I like to call our low-level jet. These show those speeds of winds in the lower levels of the atmosphere, and all these values are very marginal for tornado risk, except up here. But this is like behind the cold front, so that doesn't really matter. Yeah, and then even as we can see get into the evening hours, they increase a little bit on the northern mode, but still not too much. This is really all just convective interference here, and then this is like behind the cold front, and there's not really, or right along the cold front, but there's not really any instability there because of the earlier storms that come in like the afternoon or evening hours compared to getting like the afternoon and early evening compared to the late evening storms. There's not really enough instability, so even with that little bit of stronger low-level support in the wind shear department, there's just not going to be enough instability for severe weather. See, again, we're just going to take a look at our storm relative helicity values quickly, and they'll be very low across most of the area. Here, look, and the reason storm relative helicity is important is because it predicts, it doesn't predict, but it shows the horizontal motion that, if stretched vertically by an updraft, so basically it measures the potential for a tornado, because the horizontal motion, if it gets flipped vertically by an updraft, becomes a tornado. And you look for values generally over 150 to see tornadoes, and we just really don't have that in this case. You can see we get it a little bit, but by like 22Z, which is like about 6 o'clock, there's some values here, but even then the instability starts to decrease by then, so it's just going to be a very marginal risk for tornadoes. I don't really see it developing too much, but there could be like a isolated tornado or two, again, in this further north mode up here, but it's really going to be a low end risk at most. Maybe across Maine there's a tiny bit more, but still very low end risk. We're now going to be taking a look at our HRRR. This is our other model that I like to use, and we're going to take a look at its reflectivity output, and let's just get into the afternoon hours now, and we can see how storms begin to fire in the early afternoon. And here, just see early afternoon, and again, they're going to form into these clusters, perhaps even lines of storms, and again, it's mostly just shows a very similar environment where it's just going to be capable of damaging winds. It shows a very similar shear environment, I should say. The shear environment is similar to what the NAM shows, but the big difference with the HRRR is that it has much less instability for this setup. A lot of areas staying right around 1000 mixed layer CAPE, which is like somewhat supportive of severe weather. Like that's what you generally look for, values greater than 1000. But with such weak wind shear, you really wouldn't see much of a severe weather risk with that, I would think, or it would still be more localized than what is currently expected. And the reason it does show this less instability as we just play it through is because there's just a lot less moisture with this system. It gets mixed out during the day some, because you can see here by 7 a.m. in the morning, this is very robust moisture access. But then as we mix into the day some, it just decreases. And here, this decreases all the way up into the, or all the way down rather, into the upper 50s. And that, I just think, is overdoing it a little bit. No other model shows it mixing out as much. Not any of these models here, which I looked at. I won't show them for the sake of time, but they generally showed low to perhaps mid 60s dew points for this area in here. So that's why I just really don't buy it that it's going to mix out that much. So again, it will probably be a little more instability than what the HRRR shows. However, if this solution were to verify, there would be very isolated severe weather. There's just not too much, because there just wouldn't be enough fuel because the moisture just gets mixed out. We are also going to take a look at our lapse rates, and this is another thing that's not as favorable for the thermodynamics for this setup as the NAM 3K was. And this helps determine our CAPE again. And we're just going to see how the values are generally going to be less than 6 compared to them being over 6 degrees Celsius on the NAM 3K. So that's the difference. That's again going to limit the amount of instability. So the HRRR is much less aggressive for this system, but it still would support at least isolated instances of damaging winds and hail. We are going to take a look at our shear now and try and determine that tornado potential. Again, it would be very low end at most. At most, tornado is not going to be the primary risk by any means for this day, even in the areas that do have that low end risk. And you can see there's values are a little higher in this northern mode here, and this is where there could be that low end risk of a tornado, but overall it's just not going to probably be enough low level wind shear, especially when you account for the deep layer shear, which is also not going to be favorable. I mean, yeah, generally 20 to 30 knots, maybe increasing a little bit with time of like 25 to 35 knots in this further north mode. And again, the fact that it's just that tiny bit more wind shears and higher storm coverage is why there's this slight risk for this northern mode, but it's still not going to be a risk of widespread severe weather, which is certainly good news. Trying to think if there's anything else I should show. Yeah, we'll take a look at our storm relative helicity values in the 0 to 1 level, just like we did on the NAM. And I think that's probably going to be a little bit less. Yeah, we can see how our values are going to be lower on the HRRR, and that would really tell me that there's really not going to be any tornado risk. Yeah, so that really, if the HRRR solution were to come to be, there would be virtually no tornado risk, but regardless, tornadoes are not going to be the primary risk for this day of severe weather, even in the northern mode. So, there's mostly going to be damaging winds, and yes, there could be a tornado or two, so you should be ready for that, but the odds are very low for that. And we're just going to take a look at one more thing on the HRRR NAM3K. This is our cloud cover, and what we're going to see is that for the most part, there's going to be a lot of clearing in the morning hours and early afternoon, and that would allow for enough surface heating to occur to support that moderate instability. Now, we also would need a little more lapse rates than what the HRRR shows and a little more moisture return, but I don't think our cloud cover is going to limit heating like what has happened with some other setups recently for the Northeast. I know the last two chances of severe weather we've had a bunch of morning cloud cover where I am, and then the storms really haven't evolved for my exact area. They've generally happened for areas further east. So that's something that I'm noticing, is that there's going to be more clearing, and that allows there to at least be a higher ceiling for the instability. And we're going to see a very similar thing, that we'll have generally mostly sunny skies into the late morning or early afternoon, maybe even completely sunny skies. And that will allow for a lot of surface heating, very warm temperatures. And then that allows the potential for more instability to develop, especially in the low levels of the atmosphere. So I hope you enjoyed the video. If you did, please consider liking and subscribing. If I remember to do it when I'm editing, the link to this will be in the link to my Twitter will be in the description, and you could also follow me there. I post weather-related content there sometimes as well. And yes, I hope you enjoyed, and I will see you next time. Bye.